I'm going in.
Hello. I'd like to welcome you to Communitech's Data Hub. Also like to welcome the people that are watching the live stream today. It's great to see a huge turnout here for this Data Hub session on high definition maps. So let me introduce myself. My name is Mauro Rossi. I work here at Communitech overseeing the advanced technology platforms, and AVEN, Autonomous Vehicle Innovation Network, is one of those platforms. You can see the banner here. We have a few others that might be of interest to you. One related to a 5G test bed that we have here at the hub, as well as a advanced network test bed that's also located here. But today we're going to focus primarily on AVEN, the Autonomous Vehicle Innovation Network. And on this program here, let me just get the next presentation here up and going. So today's Data Hub session is titled Leveraging the Next Generation AI to Generate High Definition Maps at Scale. We have one of our partners on the project, Ecopia Technology, was gracious enough to come and do a presentation for us today here to the ecosystem, to the community, to let you know what technology is being used to generate these maps, why we need the maps, and so forth. But before we get into that, what I'd like to do is I'd like to thank our funders here. The AVEN program, we'd like to thank them for funding this regional technology development site. It's delivered on behalf of the Ontario government through the Ontario Centre of Excellence. So with their help, we've been able to put this session together, as well as multiple programs that I'd like to kind of bring to your attention here. So some of the key programs that within AVEN that we're actually helping out with is that we have some Data Hub sessions like this one here, where we're kind of broadcasting out to the community through live streaming, as well as through on-site sessions like this, topics related to mapping technology. So mapping is the key focus that our Waterloo Region technology development site is focusing on. There are 5 other development sites as well that are working on different areas: machine learning, mobility, human-machine interfaces. So you can come down to one of these sites down here if you want to get some more information about the AVEN and the different RTDSs. But we're also working on planning workshops in the coming future, where we're going to have more smaller groups of 10 to 15 companies coming in, or attendees to go through in-depth technology kind of workshops. We also have a data concierge service. So if you're looking for data, open or proprietary data, and not sure where to find it, you can put in a request, and our concierge will be able to help you, guide you to find that data that you might not know was actually out there and available for you. We also have a service for data growth coach services. So if you need some mentorship, you need some help in terms of identifying how to use data, that is something that our group can help you out with, as well as other more general areas that Communitech supports, anywhere from HR, talent, to tech sales. So we have a lot of coaching services available to our community of startups and scale-up companies as well. Not to leave out the larger enterprise organizations, we help them by coordinating these kind of matchmaking events, where we look at getting large corporate enterprise organizations that have challenges that a lot of our startups and scale-ups have technology and ideas and solutions to. So we help make those connections through these matchmaking events. So keep your eyes open for those that are probably coming out in sometime in the near future. One of the other bigger ones that's I'd like to make an announcement today we're launching is a Ventures program, an AVEN Ventures. And what this program is, and I'll jump right to that now, it's you can get, as a small startup company based in Ontario, you can get up to $50K in funding to support your technology development, to improve market traction, scaling your company. There are topics that will be covered, proposals that we're looking to accept, are related to mapping. So primarily, it'd be preferred if it was in the connected vehicle area, but we're not limiting it to that. We're also looking at related verticals, things like transportation, logistics, utilities, infrastructure. So if you have sort of mapping technology in your company that you think could be relevant to this kind of an area, keep your eyes open. And we actually have today launching the first cohort. So we're starting to accept applications between now and July 12th. And we have some links here. I apologize for the length of that link. You will be able to find it on our homepage, the openhdmaps.communitech.ca site shortly. It'll be linked through there as well. But for now, it's available as of this moment right now in terms of additional details, eligibility criteria, and so forth. So with that, I'd like to kind of hand it over to Bill. Bill is, I guess, the Vice President, Sales at Ecopia.ai. He is engaging with geospatial analytics partners to find new ways of combining vector-based maps with alternate data sets to help public entities better understand and improve their communities. Previously, he spent 5 years working in enterprise sales at Cisco Systems Canada, providing data center and voice solutions. He graduated with his MBA from the Ivey School of Business with a focus on entrepreneurship and managing high-growth companies. So I'd like to thank him again for coming here to do the presentation. And we'll leave about 10 minutes at the end of the talk for questions. And on that note, if anyone that's live streaming wants to post a question, we'll be able to repeat that at the end for Bill to see if he's any questions. We'll also try and leave about, say, a bit of time after the presentation. We'll just mill around if you have any questions directly for myself for the AVEN program or Bill with respect to HD maps. We'll make ourselves available for that. On that note, thank you, Bill.
Thank you. Thank you very much, Mo. How's everyone doing today? It's great to be back here in Waterloo. Just to give you guys a little bit of a background on our company and myself, I've been with the organization now for 4 years. My main responsibility is to manage our global partnerships. We've actually been able to expand quite rapidly in markets like Africa, Southeast Asia, and the US, and we're looking to really broaden those horizons here in our Canadian market as well. It's really exciting to be able to come back here and speak to the Waterloo community. Our entire company, our CEO did his PhD research here at the University of Waterloo. It's based on 4 years of research using machine learning in the geomatics field. We actually got our start right up the street at the Accelerator Center, and we've managed to now move and grow our organization to 30 individuals, going on 40, at the Mars Center here in Toronto. There's so many resources for all of you guys to be able to take advantage of, whether it be grants, facilities, the groups that Mauro was just talking about. So if you have any questions even on those, please feel free to stay behind after. I'm always happy to answer any questions. So let me just quickly pull up the presentation. Perfect, everyone can see? Beautiful, so in today's presentation, we're here in support of the AVEN program. It's something that we are very excited to be working with over the next sort of 2-3 years. But really what we wanted to talk to you today was HD maps and their importance and how we're building them. There's a lot of different use cases that we can use use the technology that we've built, which I'll touch on, but I won't go into too much detail. So I'm always happy to answer more questions about that a little bit later on in the presentation. But really, we want to get you guys excited about the base map that we're going to be creating, because essentially, working with the AVEN program a little bit later on, this is something that you guys will have access to and be able to experience and add on top of, so that you can create higher order applications. So in terms of today's agenda, I'll walk through just sort of what are HD maps at the start, and then we'll go through all the different use cases, and then we'll sort of wrap up with how it's supporting AVEN. So the original problem that our organization was trying to solve was we noticed that there was a massive amount of pixelated data sets that were coming onto the marketplace, high quality images from new satellite constellations, from new aerial companies, from a vast amount of drone companies, as I'm sure you've seen in a lot of sort of tech sectors that are coming up. And really there wasn't enough hands in order to understand and extract the necessary information from all of these pixelated data sets. And so what we wanted to do was we converted this PhD research from our CEO to use machine learning in order to understand important facts that can be found in this information. I can't tell you how many customers that I've run into who make large purchases, whether it be federal governments, local governments, insurance companies, navigation companies, who will buy these large mosaics of a city or even a country, maybe even a continent. And then they really don't have the manpower to go in there and to understand the important facts that are going on in this information. And so really they can't even use that investment they can't use the most of their investment that they've made. And then what that means is they can't consistently go back and review the information as new data is created. So you can't see how your environment and your community is changing. And so that's really what we wanted to address, is understanding how we can collect as much information from all of this imagery as best as possible. So what is an HD map? Essentially what we're doing is we are taking these pixelated data sets and we are converting them and creating digital twins of the communities that we work, live, play, and learn. You'll start to hear this word a lot, digital twinning, over the next few years. It's sort of becoming a hot button topic, but really what that means is our ability to digitize the physical world so that it can help and support higher order applications. I'm sure everybody here is very familiar with Google Maps. So Google Maps is really sort of the phase one of an HD map. It includes the necessary information for consumers to understand point of interest information, maybe how to get from point A to point B, but there's still a lot of community information that's missing from the Google Map information set. So just to give you an example, this is actually an HD map, a first level HD map that's created by the government. And so the City of Toronto actually does a very good job of collecting many different kinds of information sets about their city, whether it be traffic lights so that they can help route traffic in a better fashion, whether it's understanding parcel data so you have a better understanding of ownership rights, subway stops. There's many different kinds of information sets that you can start layering on top so applications can start to retrieve this data and find different kinds of relationships that are going on in your community. And so I did want to also show you sort of an idea of Google Maps. And then this is actually an example of Here Maps, which is another vendor who's trying to provide this navigation equipment. So a lot of people sometimes ask me, there's these maps already, so why do we need to have HD maps? I think that there's three main reasons. Number one, the map isn't finished. So you'd be surprised, Google Maps took about thousands of people over 10 years, and really they've only mapped a lot of the developing world, and we're just talking about some basic POI information, streets and road networks. There's a lot else that can be added on top of that. So it's just an extremely costly process and it's very slow. The second phase is there's a number of developing worlds. The developing world needs to have that information and be filled in. And then number three is there's a lot, as I was mentioning a little bit earlier on, there's a lot of advanced features that can start to help support things like autonomous vehicles, telecommunication networks, which I'll get into a little bit later in our presentation. So how do we build these maps? It took organizations like Google and Here and OpenStreetMaps many different years to build the content that they have now. The way that we're doing it is actually using deep learning. So we've actually created a semi-automated process that uses detection and modeling algorithms with a small team of quality control individuals who can help us make sure that our maps have the highest level of quality. So really what happens when you end up, I'd like to skip forward just for a brief moment. When a lot of organizations out there are throwing deep learning at trying to extract highly geometric and important information from map data, this is an example of extracting building footprints. You tend to get very nebulous results. So it's really, you can't really make an assessment of how many homes are in this picture, what's the square footage of all the property. These are the kind of questions that insurance organizations and real estate organizations, telecommunications companies want to start to have an understanding of when they start to enter into new markets. And so what we do is we're actually breaking it out into a detection algorithm and a modeling algorithm to help us extract these features with the best possible quality before they are actually sent to our team of map annotators who will make sure that we can create the best possible map for communities. And so really this is an example of the map that we will create when we're extracting features like building footprints and road networks. And the kind of things that we're looking for in imagery is we are classifying pixels based on geometry, texture, color, and actually the context of other pixels in the imagery so that we can actually find these relationships so that we can build these kind of polygons at scale. So what are the different kind of industries that are using these maps? So I've mentioned 3 or 4 of them already with the telecommunications and insurance, but you'd be surprised there's many different kinds of industries that need this kind of information, whether it's environmental, and you want to understand deforestation across an entire continent. Same thing, or it could be local government, so that you want to have an understanding of creating impervious surface maps so that you can do flood modeling and flood simulations. And even into NGOs, which I'll actually talk about briefly right here. One of our biggest success stories is actually we are going to go out and map all of Africa. That's what our hope is over the next 6 to 12 months. And really what we'd like to be doing if we can move forward with this opportunity is trying to extract all building footprints and roads over an entire continent. So really filling in the map over all of the developing world. And how that's helpful if we can manage to put this opportunity or this initiative together is really trying to help out with vaccination control. So I'll give you an example. These are the maps. This is Google Map and OpenStreetMaps. These are the 2 maps here. And so organizations like the Bill and Melinda Gates Foundation, right now they are using maps that they don't have an understanding of where populations are living. And you can imagine when you're trying to eradicate a disease like an infection or a disease like Ebola or malaria or polio, using maps like this can be very difficult to understand where do I have to go to, how many vaccinations do I have to bring with me? Where exactly do I need to go in order to assess them? So these are the kind of maps that Ecopia will create over the 23 million square kilometers if we're successful. And so this is just another example. So this is another area in Tanzania where we've actually done a proof of concept of our maps. So you'll see here that there is some vague understanding of where there might be buildings and populations living. If you go to OpenStreetMaps, there's no understanding. There's a few more roads, but there's absolutely no understanding of where the populations are. And then this is an Ecopia map. So really, you're allowing NGOs to be a lot more proactive with their capability of going out there and helping communities that might be less fortunate, that are less fortunate. So this is another type of map. So there's two things that we can actually help with our HD maps. It's not only just filling in the map for the developing world, but also adding advanced features for the developed world here in North America. So I'd shown you a map of what the Toronto government has in order to help them assess and manage the community. But this is a map that we had created. So you'll see here that this is actually a map that can help them in a much better capacity with their impervious surface analysis. You really understand where every single building is in the city, and you can actually create a 3D representation of everything that's going on. And so this 3D representation can also be very helpful for cities that are looking to enable smart cities. So one of the key things for smart cities is actually being able to install a 5G network. And one of the difficulties with a 5G bandwidth is it's actually quite finicky when it comes to interference. So even the differences between deciduous trees and coniferous trees can have a significant impact on how that bandwidth or on how the signal is actually received. And so these organizations like Ericsson, Nokia, and the big service providers, they need to have a very thorough understanding of a 3D environment, not only just in terms of the types of buildings, the height of buildings, but also the types of vegetations that are all through the city. And so that's actually what we're doing right now in the United States and in Europe, is we're helping these organizations create very thorough 3D maps of their environments so that they can have a faster rollout of their 5G infrastructure. One of the other ways that we're using our maps is because we're using automation, we can actually create change detection in a much faster methodology. So actually, for every major hurricane that has taken place in North America over the last 2 years, we've actually gone out and we've done a pre and post evaluation of every area and done a damage assessment of all the properties within that area. So we can actually help reinsurance companies get the necessary personnel on the ground to help these communities in a much quicker fashion. And we can also help them assess the damage that has taken place, not just with buildings, but also important infrastructure like airports, bridges, and key roadways. One of the last things, this is getting closer, we're getting closer and closer to how we're going to be supporting the AVEN program, is HD maps are very helpful for navigation, logistics, and automated vehicles. And so one of the key aspects of creating HD maps are in navigation particularly is something called last mile navigation. So Google may have a great understanding of all of the different roadways that are in a city, but really when you have to get to a certain address, it starts to fail you when you have to understand, how do I get from the roadway to the actual delivery door or to the front door of the apartment building? Without this kind of information, you can't have an automated vehicle be able to navigate on the property so that it can actually lead to the actual delivery area. You wouldn't believe how many minutes are wasted if you're losing 1 minute per Uber ride over 1,000 Uber drivers over 100 trips a day. There's a lot of inefficiency that happens if you have no understanding of how to get from that roadway through a large property to the actual to where your actual customers will be located. And so this actual map, what we're doing here, this is similar to the Toronto map I was just showing earlier. What we're showing is all the different driveways and all the different parking lots across Toronto. And so what we're also doing is we're actually, once we have created these vector maps, what we want to do, working with other organizations and other startups like yourselves, is start to add additional information on top of our vector polygons. And so really this is an example of what geocoding looks like for a lot of rural areas in North America. And really there's no geocoding at all in some other countries in the developing world. And what this is actually called interpolated data. So these are where all the address points are on your map. And so that's what happens when you actually put something into your navigation equipment, and then it leads you to either past an address or not to the actual building. And so what we actually created for all of the United States is we've extracted every single building, 170 million buildings across the US from 2018 and 2019 satellite imagery. And what we've done is we've actually geocoded every single structure so that you can have a precise understanding of where all of these buildings are across the entire nation. And we're keeping that up to date on an annual basis so that you can have the most up-to-date maps and understand exactly where you're going, whether you're delivering something, picking somebody up, or really just making an assessment even on a property. So the last thing I sort of want to bring up, this is getting closer and closer to how we're going to be supporting the AVEN program, is extracting those advanced kind of features which I talked about earlier in the presentation. Really, we started with building footprints, we evolved to roadways, but now what we want to do is extract many other types of features that will help with the rollout and expansion of autonomous vehicles here in Canada. So really what we want to be doing is laneway center lines, left turn, right turn lanes, crosswalks. We really want to extract every single feature that will be important for applications that will help drive the next phase of automotive vehicles. And that's where we're going to be working with the AVEN program. Is we've actually been invited to extract this kind of data set across all of Waterloo. And that's what we're going to be providing in a platform method, through a platform to all startups and SMEs in the Waterloo area. Is we want you guys to have the opportunity to have access to this data set, to be able to play with it, to add other information on top of it, whether it's location data or other kinds of information, so that you can help find relationships and create other kinds of companies that can help us expand and push towards an autonomous vehicle future. So I wanted to pause briefly right there. I don't know if there's any questions that you guys might have. There might be a bunch, but.
Just one comment. If you have a question, if you don't mind speaking into the speaker box here, that way the people online can actually hear the question as well.
I guess I was wondering about the machine learning.
Yes.
How does that apply?
Yes. So essentially what we're doing is whenever we take an image, and I can roll back to this. So we do have a semi-automated process. So our team of map annotators will collect a training sample for any given project that we start to work on. So whatever feature our customer is looking for, whether it be a building footprint, a road network, we'll go in and extract some ambiguous examples, some different examples that don't already exist in our training sample set. And then we'll go in and we'll start to use our detection and modeling algorithm. Now the first phase here is actually our detection algorithm. What we do here is we actually make the imagery more coarse, and we're looking for less relationships. And really what we're trying to do here is just create a bounding box over every single feature that might be over the imagery. So you can imagine in our first big success, we actually were mapping every building footprint in Australia. And you can imagine in Australia, if you just picture it in your head, there's 20 million buildings, over 7 million square kilometers, but really a vast majority of that is the outback. It's unnecessary. You really don't need to be taking time on compute cycles or QC cycles to really be looking at that imagery in the outback. And so what our detection algorithm is actually doing in the first phase is it makes the imagery more coarse, it feeds it through, and it creates a bounding box, and it errs on the side of over-extraction. But what it's doing is it's allowing us to focus our resources on a much smaller area versus having to look at the entire data set. The next phase, what we're doing is we're actually looking at every single bounding box, and we're classifying each pixel on a pixel by pixel basis, whether we think it's a surrounding area, the rooftop of a feature, or maybe the wall or the facade of a feature. And so what that's allowing us to do is understand what that building looks like. And then in the final phase, and really what that's creating is a raster probability map for us. And so in the last phase, we're converting that raster probability map through our modeling algorithm into our vector polygons. And so what's neat about our machine learning modeling algorithm is it's able to avoid the issues of vegetation and shadowing. So really, whenever you're extracting building footprints, a lot of current people in the market today, whenever they have a tree that is sort of overhanging half of the house, you might get a house that has a cutout of it. And so really what our technology is able to do is to infer by seeing all the different training samples of what a house looks like, that it typically has perpendicular angles, it typically has parallel lines, that house probably continues on either side. And it can do the same thing for roads if there's vegetation over roads, et cetera. So it can look for relationships based on its previous experience with that kind of feature.
Okay, excuse me, I have a question. Hello, I'm here. Can you explain or highlight the difference what you are doing with what Planet.com is doing? They are using the AI and machine learning for detection and extraction, not only the houses and other features
Planet?
too. And other, let's say, cars, anything else, let's say.
Great question. So I think if you were speaking about Planet in particular, Planet is working with usually higher resolution data set. So it's usually sort of working with 1 meter, 2 meter data sets. The issues that you can have there, number one is the horizontal misaccuracy. When we work with any kind of different imagery, any kind of 3-band imagery, so whether it's street view, oblique, aerial, satellite, we are trying to use all different sources to come up with the most accurate vector map. The higher the source is from the ground, the more misaccuracy you might have. So Maxar is one of our bigger partners. And so what we'll see there is in the Maxar image, sometimes it could be 3 to 5 meters off from one vintage to another. And so you can imagine if you're trying to build autonomous vehicle roadways from satellite imagery and your vector map is 5 meters off, I might be driving to say hello to us right through the wall. So I'd say that the couple things that are different are, number one, we're trying to use as many different sources as possible to create as much accuracy as possible. And then I'd say the other piece is the use of our semi-automated system. So we actually do really focus on having an iterative learning approach where all of our results make it to our QC team. Our QC team repairs anything that might have a low probability of being accurate, but everything that they repair gets fed back into our training sample. So it's an iterative learning process so that we're constantly improving off of every project that we do.
Hello. I was wondering if you could talk a little bit more about the QC team, specifically like maybe some of the technologies you're using to do this, like microtasking or platforms you're using for that sort of thing?
Yes, so it's a great question. So that's actually something that we built in-house. I'd say the two advantages that we have is a scheduling algorithm that we've actually built as well. So we actually tile out a lot of tile out our workflow. So our scheduling algorithm helps us make sure that everybody is being efficient. Our best QC teams are being fed the most data. Then we also have developed a vector editing platform in-house that makes it a little bit easier for us to, it's not like we're using some of the current software that's available in the marketplace that can be a little bit cumbersome to use. It's really it's focused on just editing vectors. And we actually do have some other aspects that help identify potential problem areas, and I can't go into too much detail, but help make our QC team more efficient. So it's really trying to keep things simple in terms of the program that we've developed for them, but then also trying to give them as much work as as they can keep up with, but then also helping them identify problem areas.
Hi there. There's an old saying in geography that the map is not the territory. I don't know if you've ever heard about that one or not.
No,
okay.
unfortunately.
But your example about the Africa mapping really kind of stuck with me. Thinking about you might be extracting images like roads, et cetera, that exist in physical reality, but the social reality on top of that could be very contested. For example, a road might be claimed by two different countries, right? How does your company deal with contested geographies like that?
I'd say that we've been pretty good just based on the people that are consuming our maps. I think that the NGO community it's a lucky organization to work with because they do have a lot of leeway in many different kinds of areas like this, especially when you're delivering vaccines. It's something that it's a good for most people. So, and they tend to have a lot of local experience. So it's our maps are going to individuals who live and work and are trying to help those communities. So we haven't run into a lot of those issues of, we're really just trying to create that base map that can make their operations more efficient.
I want to key in on the aspect of updates and keeping, I guess, the map itself current and relevant. I can see it, obviously, it can be very application dependent. I want to key in one element of that spectrum and autonomous vehicle in particular. Mm-hmm. So having a big part of the quality of this map will be focused on being updated in real time and having real-time information, be it road closures or accidents and things like that. I think Waze sort of added to this for autonomous vehicle navigation. Is that something that you're looking into, or where do you see the future of that going? It's a lot different than sort of updating it on a yearly basis from satellite imagery. Is that going to present problems, or in a smart city context where you have everything on the street instrumented with cameras and everything like that? Is that part of the roadmap?
That is the million-dollar question, where I think a lot of different autonomous vehicle companies, telecommunication companies, everybody's trying to assert what is going to be the standard on how, because really what you need is a very capable LiDAR system on your vehicle so that it's understanding the bubble around your car. But then you also need a very high-quality HD map so that it can make the assessments of how it should be routing itself around the city. And I think that there is a lot of discussion as to how much should be done in the car, how much CPU processing should be done right at the vehicle versus how much should be out in the cloud in an HD map, and then how much communication should occur to update that map. I think that we're just sort of at the beginning of those conversations, because I think that you have telecommunications organizations who want it to be all in the cloud because they can justify more networking equipment. Then you've got some automotive manufacturers who might want to have more horsepower in the car, depending on if you're a high-end vehicle, or if a low-end vehicle, you want to be able to completely remove that from the vehicle so that you can keep your car more affordable. I think that's an exciting territory right now, is where is that standard going to lie? Because obviously there will be it's going to have to be a feedback loop, but how much is done in does the HD map sit in a vehicle and then things are being updated here? Are nodes, or is every car a node, and is it updating the map in the cloud? I think we're still trying to figure that out a little bit.
So I think everyone is probably wondering, well, how do we sort of be a part of this, and then how do we sort of build on this? What is sort of the partnership model? What is the developer model that you work with, and things like that? So, yeah, if you could speak to that a little bit.
Yeah, I think that the way that we would like to be moving forward is we want to create this platform map that we would hope to expand over across all of North America, but really based on the relationships that we have with the AVEN program, OCE, and a lot of different government bodies, is we do want to be able to make this available to smaller organizations so that they can have the opportunity to be playing with this data, and so that they can understand, maybe I can use this for a specific kind of delivery application, or there might be in a lot of different ways. So we do want to make this available. I think over the next 4 years, we will be building out this, we'll be continually sort of adding towards the kind of information that'll be added. Emily can actually help with that.
Hi everyone, I'm Emily with Ecopia as well. So with AVEN right now specifically, we're working in the Waterloo Region. The goal of that is to create the base map. And the base map will be inclusive of all kind of features, so road features, curbs, center lines, those various things. And then the goal is to add, by way of partnership, additional layers and attributes on top of that. So that will be housed in the platform, open to SMEs for free as part of the program. And then we're hoping that through the AVEN program itself, as Mauro mentioned at the beginning, there's 5 additional RTDSs across Ontario. We're hoping that we can kind of move this model across Ontario, and then hopefully use this as a jumping off point to make it more broadly available. But right now in Waterloo, our goal is to create the base map and to encourage additional partners to add attributes on top of that. So there are features that are within that we will be creating as part of the base map, but things that we're not touching on that we're going to look to the partners to add additional value on top of the base map itself. And that's open for collaboration for the purpose of kind of manipulating the data. We'll make it all available for Waterloo Region, and it's a rolling process. So we're getting started now with the imagery collection and with the feature extraction. We're going to do portions of it over the next couple of years. So we're starting with a 5% area of Waterloo Region. So it'll be the full region itself, not just the city. And then we'll make that all available by way of the platform. So Mauro, I'm sure, will share updates when those features and the extractions are done, and put that out to the community to use and interact with. Sorry, that's yours.
Yeah, and logistics-wise, the AVEN Ventures, for example, is our first foray into that area. So in terms of looking for proposals on how to participate in this project and looking for some kind of funding opportunities. But there's also partnerships we're open to. So if you have any kind of questions, check out the links that were showed up earlier. We'll put them back at the end of the presentation up there. Feel free to reach out to myself as well. It's all on the webpage there. And we're looking for all kinds of opportunities, the connected vehicles, but even similar type sectors as well, that, like we talked about, real estate in terms of some of the telecoms. So it's a much broader group that we're trying to look for as well.
Yeah, I think we'd love to be able to expand this across all of Ontario. So.
working on water main break prediction in cities. And recently, we were interested in having some maps, radar images, processing radar images, and see how are the movements, even the small movements in vertical direction, or if a city is sinking in some part or not. Is this one of the services that you provide? And would it be part of that $50,000 credit that you said? I want to try it on a couple of cities that we've worked on, London and Guelph. Thanks.
Yeah, I think that would be something that would be a perfect example of us potentially collaborating with an organization like yourself. I mean, we would create the vector map that I discussed, but I mean, that's another data set. We would like to be able to add other information. We were just talking about this earlier today, working with people who can do a subterranean analysis. I mean, that's something that is, that would work well so that we're constantly building a deeper and deeper stack of the information of the community that we live in.
Hey, I'm just curious about, as you're moving towards autonomous vehicle mapping, maybe some of the challenges when it comes to quality control. Just because, you know, if you're mapping houses, if you miss one house, then it's not a big deal. But if you miss one stop sign, then it's a big deal. So can you maybe talk about that?
Yeah, absolutely. I mean, I think that's why it was a great place to get started, was with buildings. But I think that's why we always are focused on using many different inputs. And so that's why when we're doing this implementation, we actually are going to be combining street view with an aerial view. Because you could have situations where vegetation is completely blocking out items like a stop sign or a traffic light. And so it really, the main objective of our team is to be able to merge those different data sets together and still be able to create that same extraction. And then be able to, I guess, geo-reference everything so that everything matches up. But yeah, it's about using different data sets, but then also that's why we do have a little bit of time to create it. It's going to be a bit of an iterative approach as we start to create our first draft and then evolve from there.
All right, any other questions?
Hello. How much manual work is needed after this AI process to correct some things, or is everything completely AI?
Great question. Great question. So as mentioning a little bit earlier on, we do have a semi-automated approach, and that's how we are able to ensure that our accuracy results are 95% and above. When you're working with remote sensing data, you're never going to get to 100%. There's always going to be ambiguous cases in certain situations. The more that we do a feature, as I was mentioning, because of that iterative approach where everything gets funneled back into our training sample, the better we get at a single feature. So when we're looking at things like buildings, we're getting very close to being almost completely automated with a little bit of touching up. Same with road networks. But when you start to look at new features, depending on the information source that we're extracting from, it's going to be a little bit lower in terms of the accuracy. So there's a wide range of what it could be, but you're sort of up at 90% when you're working in developed world extracting buildings and roads. But then it could be a lot lower when you're working, looking at a different kind of feature in the Middle East. So I know it might not be the answer you're looking for, but I could give you some examples of sort of where we sit on that spectrum, but the spectrum's always improving.
We have two questions from the online audience. The first one comes from Mohammed. What is the source data or imagery used for this derivative, and what is its expected accuracy? And then Michael also asked a similar question. What is the accuracy of the derivatives being created?
Okay, so sort of similar. Yeah. So again, it's completely dependent on the image source. So when you're working with things like Planet, as we were discussing earlier, you're going to have sort of 10 plus meters of potentially misaccuracy, depending if you're working on sort of 3 meter resolution stuff. When we do our satellite extraction for our NGOs in Africa, there's ways that we can tie it down to improve upon it, but you're sort of looking at 3 to 5 meter, which tends to be all right when you're working with organizations who don't have any map to speak of today. But then as we sort of shift and we work more in North American, and we work more in North American markets for civil engineering use cases, for insurance use cases, they have a much higher threshold for data accuracy, and so that's where we're getting into sub-meter to centimeter accuracy, to a few centimeter accuracy, depending on what imagery source or LiDAR source or whatever data source we're actually going to be intaking. That actually is the biggest determinant of our accuracy. So we're working with some logistics organizations in California actually right now. I would still say it's very early on in the process. I think, as I mentioned earlier, I think Kevin had a great question. Sort of how is that updating process going to take place? What is that communication method going to be like for new cars, or maybe even for retrofit vehicles? Are we going to be able to retrofit old cars with things so that? But really, that sort of comes down to what kind of network is in place. So I think it's been very experimental to date. I think a lot of these maps that are being extracted are for closed courses in small areas. We have done an extraction on open road in California, but again, it's almost like a closed course because it's a very defined area. So I think that on a very small scale, this is the very beginning of the process. But again, I think what you're going to need to be able to roll out maps like this over all of North America. And the way that the length of time it took us to build the first navigation maps that we have, it really took too long, I think. It's over a decade, and we're still filling gaps in the information. So really that's where we sort of see this, is we're building our capacity right now, so that we're ready for a year or two when we understand all the different features that are necessary, which we're sort of working out right now through this project. So it's very early stages, I would say.
The geocoding example you gave, where you're adding some sort of identifier to all buildings, that's an identifier you've made up yourself, right? You're not tying back to some government-issued identifier or something like that?
No, so actually there's a few different ways that we can geocode. Another great question. So I wanted to use that as the first example of us collaborating with other information data sets. So we will create the geometry. That's what we're very good at, pixel conversion. And that's where we really see ourselves. And I think that's the environment that we want to build, is a whole bunch of companies that are very good at their slice of the pie, and that work together so that we can build this great stack of information. And so actually in that particular example, we actually converge parcel data, which can be government. So we're taking parcel data from the government. We're taking geocode information, which uses some parcel data, but it's also from 3 or 4 different vendors. So what we're trying to do is we're trying to collect a whole bunch of different information and just clean it up and make sure that their information is, because a lot of geocodes today can even just be parcel, so center of parcel. So you can imagine if you have a big farm, your address is all the way out in the field. So what we want to do is just be able to work together to clean that up, make sure that it's a structure focused on the main building, and so that you have a much more accurate representation of where you need to be going. And then maybe on top of the next stage is pointing out with that building entrance and egress points and drop-off zones. And so then for that address, this is where your trucks will go, and then this is where your taxis will go. I love that mic. It's very durable.
You said
Sorry, I just realized I have to be repeating questions as well. So sorry to anybody online. So the question was using multiple sources of data and how are we sort of tying those down? There's a couple different ways, especially if you're working with street view, which is slightly different than working with maybe an aerial view. I'll give you one example. The easier example is with aerial and satellite. You can actually tie down using you can either use ground control points or you can actually find different anchors in the imagery. So when we actually built out all of the building footprints across North America, we were using satellite imagery. But some of our engineering and insurance clients, they really couldn't have 5 meter plus misaccuracy, because then you could have buildings that are bleeding onto other parcels. So what we actually we worked to also get aerial information, aerial data, which had a much better resolution, and then we tied it down on a tile by tile basis to the aerial imagery. Now the aerial imagery was from 2010. So we needed something of a much more recent vintage. So really what we're trying to do is take advantage of the horizontal accuracy of the aerial and the recency of the satellite, and you can find important sort of features in the ground or buildings to match them up, and then you're going to get the best of both worlds. So there's a way to tie them together. It's really like most of it is an anchoring approach. So you're picking specific important features, and then you're making sure that those are aligned.
We're live again, so.
We have one more question from the audience online. Tim would like to know what steps are being taken to prevent this data from being used for illicit purposes.
Illicit purposes. Illicit purposes. My creativity is well, I'm just trying to get an understanding. I mean, a lot of data is available as it is today. We are going to be creating a platform that just has a much more rich information set, but a lot of people can use maps like Google. I guess I want to understand a little bit more about illicit ways.
I'm going to jump in. So right now, because our information isn't available openly on a platform, we control who the customers are and how they're receiving it, and we understand the use case of why we're creating the data layers for them right now. So the process for us right now as it stands is we work with either through our partner channels or directly with a customer. They describe the area of interest. We understand the application, which is how we either source imagery for them based on what their needs are. So, I mean, we really understand what our customers and what our partners are using this for. So right now, it's not available openly, so it can't just be accessed to be used for whatever. So as we continue down the path of creating platforms and making data available, we'll have to consider those things and those quote-unquote illicit use cases. But right now, it's just not something we've really had to work with or against.
Better answer, yeah.
That is the communication side of me.
Yeah, it's been focused on a customer by customer basis.
Over here, Bill. Okay. Another question. So it's again back to autonomous vehicle. So there's some that feel that whoever owns the curbs in cities really will own the autonomous vehicle market because there's so many transactions that will happen along the curb. And there is a data set out there, it's called Open Curbs. How would that be integrated into something like that so that you could instill that kind of rich information within your platform?
I guess it would, I'm not familiar with Open Curbs, but it would depend on the accuracy of Open Curbs because I've had some experience with open data, OpenStreetMap. These kind of platforms, if you don't have a thorough understanding of where those curbs were extracted from or what the quality of the data was behind those curbs, it can create a situation where it might not be that valuable. So it would depend on. I'd like to learn more about open curbs.
Sounds like it could be an interesting Avon Ventures program or project.
All right, we probably have time for one last question before we have to wrap it up.
Last but hopefully not least. So you're a pretty busy company. You've got 30 people that are going to map Africa in the next 6 months. Pretty big
Hopefully,
undertaking.
yes. We'd like to.
It's pretty incredible to even
initiative.
think about.
Yeah.
So when do you think the region of Waterloo HD map might be ready?
What's the latest timeline?
Imagery collection is happening right now, and then we're going to do different sample sizes. So we're going to start with 5% of the extraction, and then we'll roll that. And it's over the course of the next 2.5 years. So once the first area is available, I'm sure Morrow and Avon team will make that available to the group. But it'll be about a year and a bit from now that 5% is available.
So I think some prototypes, early stage for partnership kind of activities will be probably March of next year, with then the 5% of the region following shortly after that, and then incremental growth in like 20% increases additional and by I think 2021, the end of March 2021, there should be probably the bulk of the area covered, and then remaining another year or so for under the Avon program to continue doing additional projects with the map of the Waterloo region. That last year is looking to go to the other RTDS partners within the other regions to see if they want to develop maps using the same template, the same process that was established here in this region. All right. On that note, I'd like to thank everyone again for taking the time to come out to the Data Hub session, as well as thank the people online for the great questions. We'll probably be hanging around here for an additional half hour or so. If you have any questions, feel free to come up and ask us any questions regarding the programming, the Avon Ventures. You can talk to myself or anyone else from Communitech. Any specific questions for Bill or Emily, I'm sure they'll be happy to answer your questions. So again, thank you so much, and have a great day.